Hello friends, welcome to this video. In this video we are going to see what is law of parallelogram of vector addition, and these are some of the theory questions that you will find in exams, right? It's very important. If you understand this, then you will be able to solve some problems very quickly and very easily, and you don't have to remember anything. Here we'll derive this formula in this video, and then we'll take some problems on this formula, right? So what is the law of parallelogram of vector addition? So it states that if two vectors simultaneously acting at a point, right? Let us say that we have two vectors v1 and v2, right? So these are the two vectors. You can see the drawing. This is v1 and this is v2. So if these two vectors simultaneously act at a point and is represented by magnitude and direction by two adjacent sides of a parallelogram, then the resultant force of these two vectors is given by the diagonal passing through the point of intersection, right? So these two vectors are acting at point A, let us say, and then if these two vectors are represented in direction and magnitude by two sides of parallelogram, let us say A, B, C and D is my parallelogram, right? Then the resultant of v1 and v2 is given by a diagonal which is passing through the point of intersection, right? So parallelogram will have two diagonals, but the resultant is given by a diagonal which is passing through the point of intersection of these two vectors, right? That is point A. So the diagonal passing through A will give you the resultant of these two forces. That's the law of parallelogram of vector addition, and here we are going to derive the equation for resultant, right? So suppose that we are given two vectors p and q, and the angle between vector p and q is theta, right? P and q are vectors, and angle between p and q is theta, right? So how to derive the equation for resultant? So the resultant will be given by a diagonal that is passing through the point of intersection of these two vectors. Now let us take this diagram, right? So this diagram, the diagram on the right side, right? So we have drawn some additional lines, like we have given a parallelogram as OABC, and then we have just drawn a line which is horizontal. We have extended the vector OC, and this is the extension, and this is my parallelogram. So I will draw a parallelogram by a different color so that we can easily understand it. So this is my parallelogram, right? And I have drawn these additional lines. So additional line I will represent by some other color, that is, this is my additional lines. And now here what we have to see is this is my perpendicular that I have drawn, and this parallelogram. So this vector q is equal to this vector, right, in direction as well as in magnitude. Now geometry, what we can say that OA is equal to CB is equal to vector q, right? And angle between vector P and Q, that is angle AOC, is equal to angle BCD, that is equal to theta. Now from this thing what we can say is OC is equal to P, CD is equal to BC cos theta, that is equal to Q cos theta, and then BD, this becomes Q cos theta, and this becomes Q sin theta from trigonometry, and BD equal to Q sin. We have to find OB, right? So OB square, if we take a triangle OBD, which is a right angle triangle, just take a right angle triangle OBD. So this is my right angle triangle that I am considering, right? In this right angle triangle, what I can say is OB square is equal to OD square plus BD square, that is from Pythagoras theorem, right? Now OB is our resultant, that is R. So r square is equal to OD. Now OD we can split in two terms, P plus Q cos theta square plus Q sin theta square, right? Now this, what we can do is we can just separate this term, that is resultant is equal to P plus Q cos theta square, this was a term, plus Q sin theta square, right? So you can just simplify P square plus 2PQ cos theta plus Q square cos theta, and then this is cos square theta plus Q square sin square theta. Now what we can do is we can take Q square common, plus 2PQ cos theta, and here from this equation, from this thing, we can take Q square common, and then we will get sin square theta plus cos square theta, and that Q's 1, so we get resultant square. We have resultant square is equal to P square plus Q square plus 2PQ cos theta. So this is a formula for resultant, right? So this gives the magnitude of resultant. Suppose let us say that resultant is at an angle alpha from vector Q. So what we can say is tan alpha is equal to, from triangle OBD, what we can say, tan alpha is equal to BD by OD, and that BD is Q sin theta divided by P plus Q cos theta, right? So second expression that you can remember is this. So these are the expressions that you have to remember for law of parallelogram of factor addition. So that's all in this video. In next video we are going to solve some of the few problems that you can expect from this theory, from this area of mechanics, right? So thank you friends for watching this video. Take care. Bye bye.